All right, so moving right along here, let's get started with the ball scene. So the ball is going to be a rigid body 2D. This is a body that is controlled by the physics engine. So all these type of parameters we set over here, this is how the ball is going to move in the game. So let's go ahead and give it a collision shape 2D and also a sprite 2D. And also let's add a GPU particles 2D on here. So for the sprite 2D, let's come to entities ball and give it this ball.png. And then for the collision shape, we can use a circle shape here. Let's turn on grid snapping and match that up. And let's click on the rigid body itself and set up its layers. So it's going to be on layer 2. It's going to be looking for layers 1, 3, and 4. So we're going to handle most of the collisions on the ball itself, colliding with the world, the paddle, and the bricks. Let's go ahead and set up this GPU particles 2D here. You know what, before we set up the GPU particles 2D, let's set up the rigid body 2D itself. So let's turn gravity scale to 0. Let's turn can sleep off. We don't need that. Let's turn contact monitor on and turn max contacts up to something like 4 or 5 or just anything more than 0. This is needed so that when we connect signals like body entered or body shape entered, that these signals will actually fire. If you don't turn contact monitor on a rigid body 2D, it will not fire any signals when it collides with another physics body. So this is needed for the signals to fire, so make sure you turn that on. And another thing with rigid body 2Ds, they have some default damping involved with them. So if we go to physics 2D here, you can see this default linear damp is at 0.01. So this is going to slow down our ball. Like it's going to basically act like friction, and we don't want any friction with the ball. So let's turn that default linear damp off so our ball doesn't lose velocity as it bounces around. Also, let's add a physics material on here and turn bounce all the way up to 1. And we can turn friction all the way down to 0. So there's no friction, and it's going to bounce fully and keep its entire velocity when it bounces off a wall or a brick. Okay, now we can go ahead and mess around with this GPU particles 2D. So let's turn the amount to 100. Let's come into the particle textures here. We're going to use this particle circle texture. And I want to make sure that this GPU particles 2D is behind the ball. Let's turn the lifetime to 0.3. Let's turn fixed FPS to 0 and interpolate off. That'll make it so it's unlimited frames per second and it looks smoother. And then we can create that particle process material. So let's jump in there. And we can come down here to spread and turn that down to 0. We're not going to give it any velocity because the ball is moving, so it'll leave a trail of particles in its path, so the particles themselves don't actually need a velocity of their own. Let's turn gravity to 0. Let's come to scale here, and let's do 0.13 on the min and max to match the ball. And then let's give it a scale curve, so let's click in here, click on curve, and then we'll just have the particles fade out to 0 scale over their lifetime. Also, we can give it a color ramp here. So let's add a new gradient texture 1D and click in here. And then under gradient, I've actually included some gradients already that we're going to use for our normal gradient, and then for the multi-ball, the fire multi-balls, and the fireballs. Those are going to be upgrades that we're going to do a little later, but we can just do quick load here and select gradient normal and use that gradient that I included. And that should be it for setting up the GPU particles 2D. So let's go ahead and name this ball and save this. You can come to the entities folder and have a ball folder, save that. Let's add a script onto the ball. And let's get into this ball script. So give this a class name ball. I don't think we'll be using the class name anytime soon, but just in case we need one later down the road. Give it a const start position. Going to be equal to vector2 of 320, 312. Let's give it a start velocity equal to -90, -90. So the ball's going to go up and to the left, basically 45 degrees to the left. Let's give it a base speed of, that's going to be a float, say 130. And let's have a speed increase value. It's a float one, so it'll increase by one. What's the velocity as pixel per second? 1 pixel per second. Every time we want it to increase its speed. We're going to have a couple private variables here. Let's have a speed, and that's going to be start out as the base speed. We're going to have a var is stuck to paddle. This will be a boolean. We're going to have a var. This is going to be the stick offset. And we'll start that off as vector2 0. And then we'll have a var stuck velocity. And we'll initialize that to 0 as well. So the stick offset is how offset it is from the paddle. And then this stuck velocity is its velocity before we stick it to the paddle. So when it's stuck to the paddle, its velocity is obviously going to be 0. But we want to keep that stuck velocity, remember what its stuck velocity was, so that when we release the ball, we can return its velocity to what it should be. So let's go into the ready function here, and we'll start off by just calling reset ball. So let's create that function. And I got to get in the habit of giving that void return type, even though it's unnecessary. It will give us a little warning because of those warnings that we set up. So it looks like before we set this reset ball up, we need to do a few things in the game manager itself. So let's just put pass in here for now. And let's open up that game manager here. And let's mess around with this. So up here, let's have a couple of public variables. Let's have is game started. Let's have allow movement. And then we can also add a lives variable here. So let's go into the unhandled input function here. And we'll say if event dot is action pressed action and is game started is false. We will set is game started equal to true. We will call events.gamestarted.emit. And then we'll do get viewport dot set input as handled. So that this this spacebar action won't propagate continue propagating because we've already handled it. So let's set up this, let's go into the events, auto load here. And here under game, we can have a signal for game started. Okay, so pressing spacebar is going to start our game now. And what else do we need in here for the time being? I think that should be enough to get us started with the ball script. So reset ball, we're going to set that game manager dot is game started equal to false. We're going to set our global position equal to game manager dot get paddle position. We haven't created this yet. So we actually need to create the paddle before we can reset the ball, because we're going to have the ball stick to the paddle. And this vector 2, 0 and -8, the y, this is the offset for the paddle. So we're going to get whatever the paddle position is and then move the ball up 8 pixels from that. Let's set the linear velocity equal to the start velocity. And let's reset our speed back to the base speed. And then we'll call stick to paddle. So let's create this stick to paddle function. And this is going to be return type void. So to stick to the paddle, we're going to take our stuck velocity and we're going to capture our current linear velocity in it. We're going to take our stick offset and set it to our global position minus the game manager dot get paddle position. So the paddle's position. We're going to say is stuck to paddle equals true. We're going to take our linear velocity and set it to 0. And then this is the most important part. We're going to do set deferred freeze to true. So the rigid body 2D has a thing called freeze here. So if the body is frozen, gravity and forces are not applied to it. So basically the physics engine is going to ignore that this rigid body 2D. It's not going to try to move it or apply any forces to it. And if we didn't do this, when we release the ball from our paddle, even though the ball is moving with the paddle, it would snap back to its last position that the physics engine knew that it was. So we want to freeze it so that the physics engine stops caring about it, and then we can move it around and then we can unfreeze it. So this is a good way to get around the physics engine messing with your rigid body 2Ds. And if I had known about that back when I made the Pong tutorial, I would have used freeze instead of just deleting the ball entirely from the Pong tutorial and then re-adding it every time. This is a better way to handle the funkiness with rigid body 2Ds and the physics engine. So before we make the paddle, we're going to make the paddle here really quick. Let's just add a couple more functions here. Release from paddle. So to release from paddle, we're going to say is stuck to paddle equals false. We're going to take our linear velocity and set it back to that stuck velocity. And we're going to set freeze equal to false, so that the physics engine will take up controlling this rigid body again. And also we're going to have a function here, deflect off paddle. We're going to pass in a paddle as a node 2D. And so in here, we're going to take a var offset as a float. And it's going to be equal to our global position dot x minus the paddle's global position dot x divided by paddle dot get node collision shape 2D. So we're going to grab the paddle's collision shape 2D. We're going to grab its shape resource. We're going to take its extents dot x and divide it by that, and that'll give us the offset from the center of the paddle on the x position. So we could actually call this x offset. So our x offset, let's clamp that. So we'll clamp the x offset between, let's do ×2, the x offset ×2. So we'll have more dramatic deflection the farther away from the center of the paddle we are. And we'll clamp that between -2.0 and 2.0. So now we can grab a direction as a vector 2, and we'll take that x offset, and on the y position we'll set -1, so the ball's coming down, and it hits the paddle, and then we want it to go back up. So this is that -1 is doing that, and then we'll normalize that. So now we can set this ball's linear velocity equal to the direction times our speed. Okay. So that's identifier not found, game manager. I feel like I didn't add this correctly. Did I? Game manager. It's on line 19, game manager. We'll worry about that in a second. Let's go ahead and create the paddle. So for the paddle, this is going to be a character body 2D because we're going to be controlling it with a script. We'll name that paddle. We can go ahead and save that right off the bat. Let's create a new folder here under entities called paddle. Save that. Let's add a velocity component to it, and I've included that. We've created these and basically used these in every project that, every tutorial that I've been using so far. So let's set the max speed to 150 and the acceleration to 10, just so the paddle feels nice and snappy. Let's add a sprite 2D in here. Let's add a collision shape 2D and duplicate that. So this second collision shape 2D is going to be the deflect shape 2D. And let's go ahead and grab the sprite for our paddle here. And we can come to the 2D scene here, zoom in, hit F to center. So this collision shape 2D, let's create a rectangle shape here. And I don't want this to cover the top 2 pixels of the paddle. So it's going to be 2 pixels down from the top of the paddle. When the ball hits this top of the paddle, I want it to deflect. But if it hits the sides or the bottom of the paddle, I don't want it to deflect. I just want it to bounce like normal. That's why we're having 2 different collision shapes here. So this deflect shape, we're just going to have it cover just the top 2 pixels across the top of the paddle here. So this is the only area where we can deflect the ball from. So let's go ahead and access this velocity component as a unique name. Let's turn the collision layer to paddle. And for its mask, we'll just have it collide with the world. So when we hit the edge of the screen, it'll collide. And let's create a script for this. Up at the top, we'll have a start position for the paddle as well. This will be a vector2 equal to vector2 of 320 and 320. And var is ceiling hit. So in normal breakout, whenever the ball hits the ceiling for the first time, the paddle actually shrinks. So we need to know when the ball has hit the ceiling for the first time, and we will shrink the paddle. Let's drag and drop our velocity component in. Let's drag it, hold control, and drop it in. And that'll create an onReady variable for us there. And we'll come into the ready function here. And we will set game manager dot paddle equal to self. So on our game manager, where am I storing paddle? Okay. Come to our game manager here, and we need an onReady var for our paddle. So let's create an onReady var paddle, and this will be a character body 2D equal to null. So this is where we're going to hold this paddle variable on the game manager so that we can access it easily from other scripts. And we're going to set that here in the ready function. So let's set up some paddle movement. So let's come to the process function, and we're not going to be using delta, so we can put an underscore in front of that. Say if game manager dot allow movement, we will do var direction as a vector2 equals get direction. And we set this up multiple times for our velocity component. So it's going to be the same thing. This is going to return a vector2. So our X movement will be a float. It will be equal to input dot get action strength of our move right minus the input dot get action strength move left. And then we can simply return a vector2 of that X movement and 0 on the Y, because we're never going to want to move on the Y axis. And let's make sure we normalize that. So now we have the direction that we want to move based on the input. And we can simply say velocity component dot move ourself with the direction. So having this velocity component just as a drag and drop that we can always, drag onto anything that we want to move, it's a really nice thing to have. And we can reuse it across projects and across different entities that we need it on. So that should do it for the paddle and the ball. So let's go ahead and add the ball into our scene, and let's add that paddle into our scene as well. And let's come here. So the paddle start position, I believe, was 320 by 320. So start it there. And the ball's start position was 320 by 312. Oops, that's its velocity. 320 by 312. So the ball's going to start right stuck on the paddle. So let's come back to our ball script and let's see what's going on here. So we're resetting the ball. Its position, its velocity, its speed, and then it's sticking, and then we're sticking it to the paddle. So it's already going to be stuck to the paddle when we start the game. And then we have release from paddle. So when we So we're going to need a way to release the ball from the paddle. And where do we do that? So right below ready here, let's come into the physics process. And we'll say if is stuck to paddle, global position equals game manager dot get paddle position plus our stick offset. So now we need to make this get paddle position on the game manager actually, because we're using it all over the place and we never actually created it. So let's come right here and we'll say get paddle position. This is going to return a vector 2. And we'll just return the paddle's global position. So what is actually controlling us from unsticking the... Okay. We're going to want to connect to the onGameStarted event. So let's go to gamestarted.connect on gamestarted. And we'll just put this right here. So we'll say on game started. We'll release from the paddle. We can put an underscore in front of delta because we're not using it there. So let's come to our game manager and let's make sure that we are, we're emitting that game started event when we hit spacebar and start the game. So that will come into the ball and we're connecting to it here and that will release it from the paddle. So I think we're good to go on testing this out. So let's hit play and we get an error because paddle is null. Get paddle position. I believe that is because in our game here, we have the paddle below the ball. And so the paddle, I think, correct me if I'm wrong here, but I think the children run their ready functions from top to bottom. And because the paddle's ready function hasn't run its ready function and set the game manager paddle to itself, then when the ball comes to its ready function, it's calling get paddle position, but the paddle position is not set yet. So I think all we need to do here is put the paddle above the ball, and then the paddle's ready function will run first, set the game manager dot paddle object to itself, and then when the ball tries to use it, it'll be there. So there we go. So we can move around. The ball is stuck to the paddle. We can hit spacebar and release the ball from the paddle, and boom. There we go. And the ball is deflecting as it should. If we hit from this side, okay, the ball's not currently deflecting. So we didn't set that up quite yet. You see how we're doing on time? Yeah, we're doing all right on time. So let's get that that paddle collision working on the ball itself. So let's come here and let's connect to this body entered signal on the ball. And actually we don't need to use this yet. We actually need the body shape entered signal. Because we're trying to look for that. We're looking for this deflect shape 2D on the paddle. So when the ball hits the paddle, it's going to give us this body, the paddle itself, the root node. And then we're going to search its shapes and find this deflect shape 2D, whether it's on there or not. And then if we do find that deflect shape 2D, then we want to deflect off the paddle because we know we've hit the paddle. So let's do var shape name. So we're gonna equals body dot shape owner get owner body dot shape find owner body shape index dot name. So this will give us the name of the collision shape on the paddle. And if we find this deflect shape 2D, then we will bounce. We'll say if shape name is equal to deflect shape 2D, we will deflect off the paddle. And we'll pass in the paddle as, because this body here is the paddle. So we're not using this body RID and we're not using the local shape index. So we can put underscores in front of those. So this should be enough to have us call deflect off paddle when we detect that we hit that collision shape on the paddle. So let's see, this should deflect backwards. Yep, now it's deflecting correctly. And if we hit the bottom of the paddle, it won't deflect. It'll just bounce, keep bouncing the same as if it hit anything else. And it will only deflect off the top surface of the paddle, which is what we want. So that looks great. All right, on the next episode here, we're going to work on destroying bricks and working on the UI and the rest of the game logic. And we're very quickly going to be done with the base breakout, so we can get to the fun stuff of adding all the upgrades and stuff like that. So I'll see you on the next one. If you made it to the end of this video and you're keeping up with me, go ahead and, you know, like, follow, leave a comment, all that kind of stuff. And I'll see you on the next one here.